It has been more than 2,500 years since the wise Confucius wrote, "I hear and I forget, I see and I remember, I do and I understand." 23 centuries later, Jan Amos Comenius, the founder of European pedagogy, was looking for the most effective and most fun ways to pour knowledge into pupils' heads as best as possible. He described his experience in the book Schola Ludus, a school by play. He has also written a number of other books supporting effective educational methods, such as Orbis Pictus, the forerunner of the today's illustrated encyclopedias. The current Schola Ludus of the 21st century are simulation and simulation games based on computer models. Internet brings other possibilities. The development of the Internet makes it possible to connect hypertext, graphics, and simulation games into one electronically accessible unit. This is probably the future of the ebooks. Future ebooks don't just have to contain text and graphics. They may also include training simulator. However, creating web simulators is not easy. It requires multidisciplinary works of educators, model makers, programmers, and artists. One of our modest contributions in this field is the online Atlas of Physiology and Pathophysiology, which we are creating at our faculty. The Atlas is freely accessible at www.physiome.cz. Recently, major changes have taken place in web technologies that block the further use animations created with Adobe Flash technology in web browsers, but on the other hand, they open up completely new possibilities for simulation calculation directly in web browsers. Our Atlas is therefore currently undergoing a major renovation, so please be patient. New Internet technologies have brought completely new possibilities and new challenges. The current challenge is a new generation of electronic textbooks with educational simulators, which bring completely new possibilities for explaining complex dynamic relationships using simulation games. It would be beneficial if the simulator could also be part of wiki interface. We want to develop training simulators that be independent of the platform and operating systems on which they run. A common element of computing devices, from smartphones, tablets to computers, regardless of the operating system they work with, is the web platform. If we want to create platform-independent simulators, Internet browsers are the only way to achieve this goal. It is important to realize that Internet browsers have changing dramatically in the last few years. Gone are the days when we had to rely on proprietary third-party solutions like Flash or Silverlight to create desktop-like applications in the browsers. Thanks to the persistent international efforts of volunteers, standardization groups, and large Internet companies, the availability of shared libraries, framework, and software development tools makes it possible to create web applications like never before. When programming numerically demanding applications, we are not limited by the slow speed the interpreted JavaScript. The new WebAssembly standard allows us to run numerically demanding calculations directly in browsers. Therefore, it is possible to run complex simulation calculation in the Internet browser today. The web browser is now what the personal computer operating systems was in the 1990s. After many years of web browsers wars, with various web browsers manufacturers competing with each other, the agreement has finally been reached on the new web standards that will contribute to web applications development. The new web standards seek to reduce the need to implement different plugins and seek options that replace what plugins previously offered. For example, the Flash Player plugin has been used for animation in browsers for many years. It has now been removed from browsers because we can create animations in the browsers even without a Flash Player. Animations options are provided by the new HTML5 standards, which introduced an animation canvas on which animations can be created using JavaScript. The new ECMAScript 6 language standard has extended the possibilities of the JavaScript. Modern browsers have implemented a new web standard called WebAssembly, which defines a special language format for portable machine code executable web pages. It allows you to execute code almost as fast as native machine code, significantly speeding up calculations performed directly in a web browser. The Web Component Standard has been defined, which allows you to create reusable web components as a new HTML elements. Simulations are frequently used method today, not only in science and research, but especially in industry. Simulation models are usually created in specialized development tools for simulation models. However, if we want to use the model in the industrial application, we usually have no choice but to manually rewrite the model into the appropriate programming language or create our own software to connect the translated model from the development environment with the appropriate industrial application. Another problem arises if we want to connect more models in a more complex technological application, often created in different development tools. This is a situation that often occurs in the automotive or aerospace industries. Therefore, in particular, the industry has supported efforts to develop certain standards to facilitate models interconnection. The result is a new international standard, FMI, Functional Mockup Interface, which defines the methods of connected simulation models to each other and the environment. For example, according to this standard, we can translate the source code of the model in the modelical language into standardized source code in C language, accompanied by other descriptive files. But it's not just a piece of C code that we can use as one of the components in creating a software application. This component contains a model with which it is possible to communicate in a defined way. Enter parameters and initial values, start the model, stop it, change its parameters, and start it again while continuously sending input values and monitoring how its outputs react them. It's such a magic box called Function Mockup Unit with a hidden walking simulation model. It may be part of a program that controls a technology, or it may communicate with another model hidden in another component also created according to the FMI standard. The Functional Mockup Interface standard thus widely opens the door to simulation models' practical use in many fields. And just as web standards have stimulated the current boom in web technologies, new modeling standards contribute to simulation development. Both modeling and web standards are key for creating web simulators. Our new web simulator creation technology, called Bodylight.js, is based on the open web and modeling standards. We create interactive animated graphics in JavaScript and HTML5. For example, the Animate program from Adobe allows you to create such graphics. A model created in the modelical language is first translated into C language according to the FMI standard. Our technology then translates this model into a WebAssembly and JavaScript language, creating standardized web component. In our technology, we also create interactive animated graphics as a web component. Both the model and the web interactive graphics are implemented according to the standard of web components. This makes it easier to link the graphics web component to the model's web component and create animated graphics like a model-controlled puppet. When creating educational web simulators, we start from the conceptual design of an educational application created by an educator. Based on the conceptual design, the artist creates elements of interactive animated graphics. The modeler creates the appropriate models in Modelica. There can be several models of different complexity in a teaching application. The model is translated into C according to FMI standard by the Modelica compiler. Our technology then creates the source code of the WebAssembly language model and JavaScript, which it wraps into a standardized web component. Web graphics are also converted to standardized web component. In this way, a set of web components is created from which the resulting application is then assembled. A design tool called Bodylight Composer is used for interactive application development. These tools eventually generate a web simulation application in HTML, JavaScript, and WebAssembly. This application can then be run in internet browsers on different devices and platforms in different operating systems. We can, for example, run it on a computer with the Windows or Mac operating systems, on a tablet or smartphones. All we need is internet browser. We developed Bodylight technology as an open source technology. This is the example of web simulator developed by our Bodylight.js technology. Another educational application concerns the simulation of basic kidney functions. Another application deals with the metabolism of iron in the body. The current epoch is characterized by fundamental changes in technology which change the economy, society, and way of life. Advances in technology are putting pressure on people's flexibility and increasing the needs for ongoing retraining. Lifelong learning is becoming a necessity in an increasing number of fields. In medicine, however, it has been a necessity for a long time. Simulators and tutorials with simulation games can be a handy teaching tool here. However, their creation requires a combination of knowledge of professionals from various fields: doctors, experienced educators, creators of simulation models, programmers, and artists. Creative connections between different professions and between different development tools are a prerequisite for success. However, it is not only the technology of creating simulators. The decisive condition for success is also their didactic content. Therefore, we must test the application of simulation games in teaching directly in the Faculty of Medicine teaching process, when we have feedback from our development teams with students. This allows us to modify our development models to be as beneficial as possible from a didactic point of view. We develop the technology of creating web simulators as open source. We will be happy to work with anyone interested. I and our entire development team thank you for your attention.